notes. We always value everybody's opinion. So if you have some kind of comments or want to address certain things that we should do in the future, please make sure that at the end of the presentation you will use the survey. That will help us a lot to offer new great webinars for you in the future. Well, after following this presentation, you'll be issued a certificate for attendance, and to do that, you have to have a Bentley account. If you do not have one, use ims.bentley.com to create one. Use the same email address that you signed up for today, and then automatically you'll get a certificate in your Bentley transcript. So it will appear usually in 1-2 days. It will appear in this list. So you go to learn.bentley.com/transcript, and there you'll find all the past events that you attended where we recorded your attendance there. So it should appear there in a few days. Make sure that you use the same email address as you signed up for today. Otherwise, of course, it cannot connect to the profile and your attendance here today. Before we're going to start, I have a question for you. Of course, the main topic for today is: do you want to is the Norsand model and static liquefaction? So, my question to you: do you consider static liquefaction an issue? Now, please answer the question here. You can answer that that you hardly encounter situations where static liquefaction is an issue. Or maybe in practice you use mostly empirical relationships in combination with monitoring to deal with liquefaction type of problems. Maybe use limit equilibrium solutions for this. Maybe already using Plexus with Norsand for liquefaction assessment. And you just want to learn a bit more here about this today. Or maybe you have another solution, and if you have another solution, I'm always willing to hear what that solution is. So if you use a comment in the Q&A on that, for what type of solution you use to deal with liquefaction, I'm really eager to hear about that. So if you please answer the poll here, and then let's get ready to start here. So today we're talking about the Norsand model for modeling static liquefaction. My name is Michel van der Sloot. I am the Senior Manager of User Advancement here within Bentley Geotechnical Analysis. I'm really happy here that today Dr. Sandro Brazil is joining us here today. He is the Senior Manager for our Geotechnical Research Department and was directly involved in getting the model ready to be used within Plexus. He worked together with Mike Jeffries in order to have the proper implementation and the proper validation for the implementation that we have here within Plexus, and also to deal with certain modeling assumptions from the Norsand model, how it can be applied in a finite element approach. And I think that was a very interesting cooperation. So for sure, Sandro is here ready to help us with some more technical insights. So I think that's a very good takeaway for today. So what we're going to talk about today, we're going to have an introduction of the Norsand model, why it's important that we have a model that can deal with static liquefaction. Then the Norsand model, and going to have a quick look at all the different parameters and what they mean, and also some insight how to obtain them. Next step will be, of course, when we know what the parameters are, how can we calibrate those models to be used in the finite element approach? Because what we measure in the field and gives us a parameter might have a slightly different meaning when you go to a constitutive soil model. So how does the numerical simulation relate back to the real test data that you have? We can use Plexus soil test for that, but also Plexus soil test is a very good tool to learn about the model, and I'll show that also in a small demonstration. And then we have a case that we going to use the Norsand model and also focus a bit on the results. So here are the questions here, the answers to the poll question. Interesting is that like a third hardly deals with static liquefaction. So welcome here to for those people that are here to learn something new. Also, the third is mostly dealing with empirical relationship in combination with monitoring, and a fair portion is using still the limit equilibrium solution for this to assess the problem for static liquefaction. And I'm happy to see that 10% is already using Plexus with Norsand for this. So I hope we can, after this one, more people are willing to deal with this static liquefaction using Plexus. And a few people use other solutions. So if you have time, please use the Q&A, the questions and answers, to give some comments on that, because we're really eager to learn about the other solutions that people are using. Okay, let's get started. If we look at tailing deposits, yeah, we see that if you look at sort of the amount of tailing deposits that we have over the years, it's still growing, and actually it's accelerating in terms of expected volume of tailing deposits. And of course, we need to have proper reservoirs and most of the case dams to protect those kind of tailing deposits to not spill in our environment. Now, what we see also in terms of, and that you see on the right-hand side graph, is that the number of accidents that happen with these tailing storage facilities, they increased sort of around the 1960s. And slowly we see that the number of accidents are decreasing. But what's more interesting to see is that although sort of the minor accidents and smaller kind of failures happening with not that much damage and consequences, those are decreasing, so we get control on that, but we hardly see any decrease in the more serious failures. So that's something to be worried about if you think of understanding what's happening with these tailing storage facilities. So if we have a more historical look, yeah, in the 1980s in the United States, there was this dam. This was a hydraulic fill dam, which was a very common way of constructing the dams in those early 1900s, because it was a very cost-effective way of constructing a dam for a reservoir. But during construction, these kind of dams often failed. Now, then the work of Casagrande started, and at that time the concept of a critical void ratio was discovered. But despite all these very interesting scientific developments, we still see tailing dams failures in the years. You can see a few examples here. Now, not only we better understand the construction process, but the operation time, it's still not always 100% understood. And in the recent years, we still see a few big failures that happened, of course. So if you think about the Fundão Dam in Brazil in 2015, but also more recently, the Brumadinho Dam in Brazil. I think everybody who watched, you try to find this on YouTube, you can see this failure happening in really a rapid amount of time. Like within 10 seconds, the whole dam collapsed and failed. So in that case, the dam, even without having extensive monitoring, piezometers, displacement in kilometers, it didn't sort of give real prediction that this was going to happen, but still it went really quick from a drained situation into a very rapid undrained failure. So this is something that's not easily understood. Also, if you look at all the reports that happened from that, it's tricky to understand what's happening for that. And also, more importantly, the consequences when this happens, they were very serious. There were a lot of loss of life. The damages, they go in the billions of dollars, and these damages are so big also that the existence of the mining companies are even at risk. So that then, of course, it could be a risk also for external stakeholders, insurance companies, investors, that they do not want to be involved if we do not understand what's exactly going on. So there are a lot of serious consequences when these dams fail. So of course, in order to do that, we have to have a better understanding. During the development, the Norsand model emerged here to take into account the effect of static liquefaction, which is based on the critical state soil mechanics. So we have to understand the critical void ratio, role of dilation, and yeah, what's important about the Norsand model, this is one of the few models that can actually capture soil liquefaction in a very reliable and easy to understand manner. So, and this is well known in geotechnical engineering community. I know Sandro has some nice insight on the inside of the history of the Norsand model. So I'm not sure if you want to contribute that here, Sandro.
Thank you, Misha. So welcome all, first of all. Very happy to be here. What I can say about the name, firstly, why Norsand? Why the sand primarily, as opposed to camp clay, I suspect. So clay, sands against clay. That is more connected to